Um, the agenda for the rest of the semester up through the seniors' last day is on My Notre Dame. Right? There's a chapter 15 test. The juniors will take this. Seniors, if you would like to take the chapter 15 test because you want another opportunity to raise your grade, you're welcome to do that. If you prefer not to, you do not need to do that. Okay?
Wait, can we drop a test for the 15 test?
No. But you can take the 15 test and hope to do well.
Wait, don't we drop the lowest test?
You drop the lowest quiz. Okay, hold on. Shh. I have more stuff. I have lots of stuff. Okay? Shh. So, seniors, if you have to take the exam for this class, your exam will cover through all of chapter 15. Okay? So that material will appear on your exam. Just like in first semester, I'm going to give you an exam study guide. If you complete the study guide and turn it in before the end of the last day of class, I will give you extra credit on the final and allow you to use that study guide on your final exam.
Yes.
Okay? Juniors, you guys will get the same treatment, but when it's time for your final exam, you have to wait a month. Is everybody okay with that plan? Yes. Okay. I know you guys want to work day to day. I have that scheduled for Tuesday next week. I'm going to be gone that day. So I'm going to bulldoze through the rest of 15.4 and 15.5 today. And then you guys will just have stuff to work on Tuesday. Okay, with that plan. Lily.
Do we take our final in here during class?
No, you typically do that in an alternate location. They've been in the media center last year, I think. So I just give you guys your stuff, and then the counselors typically proctor the exams. Gianna.
When are you going to allow us to retake a test if we want to?
That was the next thing. So, seniors, if we go and we look at our My Notre Dame page, and you go to the very bottom under the announcements, you'll see the end of the semester survey. You can, seniors only, fill that out to let me know if you want to double a high test score or retake a chapter test. If you are planning to retake a chapter test, please let me know more sooner than later so we can make sure we have enough time for you to prepare and study for that effectively and we're not cramming it in at the very last minute. But you'll do that just by filling out the survey there. On My Notre Dame, under announcements at the very bottom.
We get no cards on the test we retake, right?
No.
No. Okay.
So far, any questions on any of this? No. Lauren.
If I have a missing quiz, that'll just drop.
I think they're set to drop a low quiz grade, yes. So that just gets dropped and absorbed into nothingness.
Okay, so I don't have to take the makeup quiz.
Not unless you want.
Mary just asked for them.
If you are a senior, put your hand up and keep it up.
Me, no, I'm scared. Me.
Mary, put your hand up. What are
So
you
this
doing?
entire right half.
Is chapter 15 going to be on the final?
Yes.
So what you are, seniors, what you're getting right now. Let me send one more back because Adriana didn't put her hand up. What you're getting right now is your exam study guide. Okay, don't lose it because you need to turn it in to me.
Yeah, I'm fine.
Okay, because it is worth 5 points extra credit on the exam, and you can use it on the exam if you turn it in. Okay. My suggestion to you is do a good, thorough job on this, because if all it is work and you don't understand the work because you copied someone else's or some AI work, it's not going to be very valuable to you. Like, really do it so you can use it.
I don't
All right, Lauren. Yes. Gianna.
Yeah.
Oh, you're just stretching or something?
yeah,
Okay,
sorry.
you're fine.
I'm not as good yet.
All right.
Okay, I'm present and ready to learn.
Yeah, my plan today, we're going to go and finish 15.4, and we're going to do 15.5. Now, most of 15.5 is going to be using a function on your calculator. Almost all of 15.5 is going to be done just using your calculator. Gianna, you'll probably have to borrow one because I don't know if your older operating system calculator is going to have this option.
Most likely not.
Okay. So just giving you the heads up there.
Okay.
When it comes time to do the homework, use the calculator to do it. So Gianna, you may have to make some other arrangements and borrow somebody's calculator or do it during class time or something. Sure. All right. Everybody cool with? So, in 15.4, we had been talking about solving exponential and logarithmic equations, right? In the second half of 15.4, we're just going to look at real-world applications that can be modeled using a exponential or logarithmic equation and talk about how to solve some story problems involving those situations. So I think I have 4 different situations. Okay. So the first is sound intensity. So sound intensity is typically measured in decibels. You guys have probably watched a sporting event where they have like the crowd noise meter at the bottom when it's like a big play or whatever, and they have the measured in decibels, and they're like, oh, the stadium's as loud as a Harrier jet taking off, or something, like the announcers do their thing. So decibels, or sound intensity measured in decibels, can be modeled by a logarithmic equation. We say beta, that's the number of decibels, is equal to 10 times the common log of I, which is the sound intensity, divided by the constant I naught. That I naught is always 10 to the negative 12th. So every time you're doing a sound intensity problem, I naught is that same value, 10 to the negative 12th. Okay? So if we look at an example, it says, given that the sound intensity of a busy city traffic is 10 to the negative 5th watts per minute squared, what is the measure of busy city traffic in decibels? So this is my value for I. Told me it was sound intensity. I know that's what I is. I naught is a constant. We have that already. So if we just plug these in, and then how are we going to finish this guy off? Type it into our calculator.
Will we be given a constant on the test?
Yes. Everybody okay with how I typed that in? Notice I didn't need to use a log base because it's the common logarithm, and there's the common log button right here on the left-hand side, just a log. Oh my gosh, that's the wrong, I typed in the wrong number. That's supposed to be negative 12 down there. Yeep. Okay.
What's the answer?
70. What do you guys think on this?
Is that DP or is that?
The dB is the abbreviation for decibels. Right here. And just a messy B. So far, so good. You ready to look at the next model? Okay. The next model is the Richter scale. Who's heard of the Richter scale before? What's it measure? Earthquakes, yeah. So the magnitude of an earthquake, R, is equal to log of alpha, which is the amplitude measured in micrometers. That's the displacement of the earth up and down. Of the vertical ground motion, the position of the earthquake. The position of the earthquake is measured T. Oh, I'm sorry. No. Okay, the vertical motion is A. T is the period associated with the wave in second. So when I say period, so this is flat Earth, right? Move up, move back down, and then back to its original spot. That's one period, right? Because the Earth, when the earthquake happens, the Earth moves up and down, right? So the start, up, down, start is one period. So that period is going to be a length of time in seconds. And then B is a constant that accounts for the weakening of the wave with increased distance from the epicenter. Do you guys know what the epicenter means? It's where the earthquake started at, right? Are we able to measure an earthquake where it starts? No, because we can't predict where or when an earthquake will happen. We don't have an instrument there to measure it, right? We have an instrument somewhere that'll record how much, displacement is happening at the location of the instrument. And then we empirically extrapolate to figure out because we know that the intensity of an earthquake dissipates with distance, we can kind of take several measurements and triangulate and figure out at the epicenter how intense the earthquake was. Everybody okay with that idea? All right. So for 27, it says, the infamous San Francisco earthquake had a Richter scale magnitude of 7.5. How many times more severe was the most severe earthquake ever recorded? The 1960 Chilean earthquake that had a Richter scale of 9.5. So what we're going to do is we're going to write a system of two equations. One for San Francisco and one for Chile. Everybody okay there? Now, we're told the Richter scale measurement for San Francisco is 7.5. And we're told the Richter scale measurement for Chile is 9.5. Everybody's good with that? So far, so good? What it's asking for is how many times more severe? When we talk about the severity of an earthquake, are we going to be talking about how much distance up and down it moved? The location of where the epicenter was, or the amount of time it takes to go up and down?
Isn't it the amount of time it takes to go up and down?
I would be worried about the distance of up and how much hard it's shaking, right? If I have a big drop and a big, big bump, that's going to tumble buildings rather than it just doing, like not moving very far up and down and just shaking a little bit, right? So what we're looking for is a ratio of like a alpha 2 divided by alpha 1, because it's asking for how many more times intense was the most intense than the least, or the lesser one. So this is what we're looking for. Everybody's okay with that? Okay. All right. So what we're going to do is we're going to solve a system of equations here. So I'm just going to take Chile and subtract San Francisco from it. So we have 9.5 minus 7.5. Equals log of alpha 1 over T1 plus B1 minus log of alpha 2 over T2 minus B2. Everybody's okay here? Okay. So first thing we're going to observe is that a Richter scale measurement of 7.5 has already had the B value corrected to it. Correct? Harry had the correction for not being at the epicenter applied, right? The 7.5 measurement was as if it was at the epicenter. Everybody agree? So in doing that, basically the B values are 0 since we're dealing with, I already have the Richter scale, the non-epicenter corrected measurement as my Richter scale, right? Does everybody feel okay there? So those guys can just drop on out of there. So now if I look, I have the difference of two logarithms, correct? What does that remind you to do? When I have one log subtracted from another. Yeah, I'm going to condense those two logarithms using the quotient property. Stupid machine. Okay. And if I divide fractions, that means I can flip the one on the right and turn it into a multiplication problem, right? Is everybody okay there? And because it's multiplication, I can reorder it to look like this. Is everybody okay there? Why would I want to reorder it so it looks like that? Because that's the thing I'm trying to solve for, right? Oh dear. Guys, I made a little oopsie. These subscripts that are 1s are supposed to be 2s, right? Because Chile is R2, that's the first thing. So those are supposed to be 1s. And those guys are supposed to be 2s. So I gotta flip everything. Sorry, guys. Sorry, it happens, all right. I didn't mean to do it. Okay, still doing okay? Now the issue is that I still have this T1 over T2. Now, I know none of us have ever been in an earthquake before, I'm guessing. But if we talk about the amount of time it takes during an earthquake for the ground to go start, up, down, back to the start, do you think that's going to be a lot of time or very little time for one like good shake? Very, very little, right? Like very, very little. Everybody agree? To the extent that like T1 is approximately going to be the same as T2. Everybody's okay with that notion? That if those things are so small, they're basically both close enough to be zero to where they're just like they don't really matter. So if they're about the same, they're just equal to 1, and I can just cancel them out. Everybody's good there? Okay. So in order to get alpha 2 divided by alpha 1 by itself, I'm going to do the exponent base of 10 to both sides. When I do that, I get 100 is equal to alpha 2 over alpha 1. So that Chilean earthquake was 100 times more intense than the San Francisco earthquake. I wouldn't want to be in Chile in 1960. Pass. Sounds real scary. All right, continuing on. Everybody's okay? The next one is about pH. How many of you guys are in chemistry and have talked about pHs? 2 people. Awesome. Way to go, guys. Take a chemistry class, you know. pH is a measurement of the relative acidity of a water-based solution. What it's measuring is the concentration of hydrogen ions, denoted as, in brackets, H+. Our formula for pH is equal to negative log of H+. Okay. pH readings start at 0 and go all the way to 14. A pH of 7 is considered neutral. That's distilled water. A pH from 0 to 7 are acidic, and from 7 to 14 are basic. The closer you are, or the further you get from 7, the more basic or acidic you get. So our example says a really sour lemon is found to have a pH of 2.2, and a bottle of bleach is found to have a pH of 10.2. What are the hydrogen ion concentrations of the 2 items? And I'm going to put a subscript at the bottom of that hydrogen ion. That's an uppercase letter L for lemon. And I'm doing the same thing over there. That's an uppercase letter B for bleach. Oops. So to get that hydrogen ion concentration by itself, what I'm going to do first is divide both sides by -1. And then what's going to cancel that logarithm? What do I do to cancel a logarithm? I'm going to use the exponent base of 10. Why 10, Gabby? Because it's the base of the logarithm. Remember, when there's no number written there, that's the common logarithm, and we understand that to be log base 10. We'll do the same thing over here. Oops. Is everybody okay with how I've come up with that? Then part B asks, how many times greater is the hydrogen ion concentration of the bleach than the lemon? So to do that, I'm just going to take the concentration of the bleach divided by the concentration of the lemon. And this answer is not going to make much sense, but because the bleach definitely has less hydrogen ions than the lemon, it probably meant the other way around, and there's a typo here in our textbook, but that's our answer. Is everybody okay? Daniel? Sure. Our last 15.4 example is about something called Newton's law of cooling. Newton's law of cooling, it describes how substances cool over time. So, Newton's law of cooling states the temperature at time t, that's T of t, is equal to T sub m, that's the temperature of the medium. So like if you are submerged in water, it'd be the temperature of the water. If you're sitting out in the open, it'd be the temperature of the air surrounding it. It's the temperature of the surroundings. That's the Tm. Plus T naught minus Tm. T naught is the initial temperature of the material when it begins cooling. So if it's the cookies that came out of the oven at 325 degrees, the cookies were 325 degrees when you took them out of the oven and they started to cool. Everybody's okay with that? K is a constant that's specific to the material that's being cooled. So for example, like the rate at which iron cools is going to be different than the rate at which a cookie cools. That the rate there is going to be represented by that constant K, which would have been found empirically. Somebody would have done some testing to calculate K. And then little t is just time, typically in minutes. Everybody's okay with the formula and what the letters mean? Okay, it says a hard-boiled egg is heated to 96 degrees Celsius in a pot, and then placed in a pot of 16 degrees Celsius water to cool. After 4 minutes, the temperature of the egg is 45 degrees Celsius. How long will it take in total to cool the egg to a temperature of 20 degrees Celsius? So if I read this, the question it's asking is how long, so I need to be solving for a time t. Everybody agree? Okay. So to do that, I need a Tm, a T naught, a K, and a T of T. Everybody's okay with that? That's what I got to fill in. Tm is the temperature of the surroundings. What is the temperature of the material surrounding the egg? 16 degrees Celsius. That's the cold water that we're dumping our hard-boiled egg into. T naught is the initial temperature of the thing we heated up. What's the initial temperature of our hard-boiled egg? 96. That's the temperature of the egg when we took it out of the boiling water to cool it off. What is the K? I'm not sure. It's not really given to us in the problem there. We're going to put a question mark there for now. And then what is the temperature of the egg at the time that we're interested in? $20. How long will it take for the egg to cool to 20 degrees? Everybody's okay with how we filled this in? Notice that we have some information that we haven't used here, right? Notice we have some information that we're missing. Guess what that unused information is going to get us? We're going to use it to find the K. We weren't given K in the problem, so we'll start by finding K. So in this case, our T of T is going to be 45. Our little t is going to be 4. The temperature of the medium and the initial temperature are still the same. Is everybody okay with how I filled this in? To solve this, what I'm going to do is I'm just going to graph this on my calculator and find the intersection. It feels easier to me than like grinding through the algebra here. You guys good with that plan? So I'm going to have 45 and then equals 16 plus 96 minus 16 times e to the negative x times 4. Everybody's good there? Values of k typically are probably somewhere between like -5 and +5. I'd be surprised if they were anything outside of that. My y is going to go from 96 to 16 at the most, right? Like the hottest it's ever going to be is when you take it out of the boiling water. The coldest it's ever going to get is the temperature of the water it's surrounding. So like 0 to 100 feels fine for me on the y's. And let's hit graph. There we go. That's the point I'm interested in. Second trace, intersect command, enter, enter, enter. So 2.54 approximately. Now that I have that value for k, I can go back and actually solve the question it asked me. So setting that up, I'd say 20 is equal to 16 plus 96 minus 16 e to the negative 0.254 t. Everybody's okay there? So I'm going to solve that the same way. Yes, sir. Yes, sir. And I don't know how long this is going to take, but I know we're solving for time, so the minimum has to be 0. And I know it took 4 minutes to go to 45, from 96 to 45. I'm guessing by 15 minutes, it'll probably get down to 20 or so. I don't really know. It's just kind of a guess. That worked, though, so I see the intersection there. Second, trace, intersect command, enter, enter, enter. So about 11.8 minutes. Everybody okay with what I did there? Okay. That's it for 15.4. So what do we got for 15.4 homeworks? Then you guys should be able to do from that up to 138. So 131 to 138. Okay. 15.5 is all about financial mathematics. Go ahead, Lily. You're welcome. So for the most part, we're going to be doing things like calculating values of bank accounts or values of investments, figuring out how much you have to save per month to end up with some amount of money later on, how to, like if you get an annuity, like how that'll work, things like that. You guys know what an annuity is? So like if you watch, like, you ever watch like America's Got Talent or whatever? And they get like $1 million prize if you win, right? Have you ever looked at the fine print on that? The fine print on it says it's paid out as an annuity over 30 years. That means they're going to pay you a fraction of that $1 million in regular intervals over the course of 30 years. They're not giving it to you all at once. Mm-hmm. So in all reality, what you're getting is way less than $1 million because of like inflation. Other situations where things come in an annuity is if like if you sue somebody and win a lawsuit, oftentimes those payouts from the lawsuits are paid out as an annuity. You're not getting like, $1 million all at once. They're going to pay you out that $1 million in regular intervals. Or like if you are a retired person, you can like sell your home on a reverse mortgage to the bank, where the bank will pay you in regular intervals while you continue to live in your house, the value of the house. But there's lots of stuff like that. Anyways, so that's something we'll talk about. But we're going to talk first about just the most basic situation, which is simple interest. So in simple interest, all your interest is calculated is from the initial investment. So that's your simple interest formula. FV stands for future value. PV is present value. R is your interest rate written as a percentage. and N is the time. So in the first example, if we invest $2,000, so that's our present value, that's the amount that we start with, at a 6% interest rate, well, that's R is 6 then. How much money do you have in the future? Well, that's going to be the future value after 3 years, so N is 3. Everybody's okay with that? So if I plug this in, oops. So that's going to end up being $2,360. Super easy, right? How much interest did you earn? Well, that's always just going to be the future value minus the present value, right? So you made $360 in interest over those 3 years. Gabby. Not if you're dividing by 100 anyway. So that's why the divide by 100 is in there. If you want to make it 0.06, just take out the divide by 100. I always just leave it in there because it's like, then I don't have to think and screw up the dividing in my head, you know? Everybody feel okay? All right. In all reality, simple interest doesn't really exist in the world. Nobody does simple interest. What almost every place does, banks and businesses and loan companies and everybody else does something called compound interest. So the compound interest formula is here. We're never going to use the compound interest formula, though. We're going to do this on our calculator where we don't need the formula. The formula is FV is future value, PV is present value, R is the interest rate as a percentage, K is the number of compounds per year, and N is the time, typically years. Okay? So the K is usually the trickiest one because they'll trick you and say like, you know, compounded monthly. What would K be if it says compounded monthly? 12, because there's 12 months in a year. If it says compounded daily, you'd write. If it says compounded weekly, you'd say, no, 52, guys. 52. Okay, you get the idea? Okay. All right, so it says you invest $2,000 at a 6% interest rate compounded annually. So that just tells you K is 1. How much money, that's the future value, do you have in the account after 3 years? So that's N, R, and PV. Everybody's okay? So if you wanted to do this by hand, oops. Sorry, times 3. You could do this. Why did I put PV there? Come on, Goober Magoo. There we go. Everybody's okay? Well, I don't want to do it that way. I'm going to use my calculator to do this. So, what we're going to do on our calculator is we're going to press the apps button that's right here, diagonal from the green alpha. Seniors in particular, I would like perk up and pay attention to this because you'll have to do this on your exam. And boy, it's a heck of a lot easier to use the finance app on your calculator than it is to try to do this by hand. So I'd follow along and try to make sure I feel at least reasonably comfortable doing this. So I'm pressing the apps button. From that list, I'm going to choose the finance app. That's the very first option on my calculator. And the one that I'm going to choose is the TVM solver. That's the first one on my calculator. Okay. So, on the TVM solver, capital N stands for the number of compounds total. So we have 3 years, right? Compounding 1 time per year. So N is 3 times 1. I is the interest rate as a percentage. That was 6. We invested $2,000 at the start. We're making $0 in payments, right? We're making 1 payment initially and 1 compound per year. What we're interested in then is the future value. Is everybody okay with where I filled things in? So now I'm going to move my cursor to where it says future value. I'm going to press alpha and enter. And out spits, oh, I should have done this. Okay, sorry. So the TVM solver has like a flow idea. So that $2,000 at the start is coming out of your pocket. So let's think about that as a negative $2,000 because it's leaving your pocket. And then when I do my calculation for my future value, it's giving me a positive value because that's money that now comes back to me. Is everybody okay? So my answer then, I would just write $2,382.03. On a test or a quiz or whatever, the amount of work that I would expect shown from you guys would be just what you filled into your calculator. If you just wrote down your entries, that's good enough for me in an answer. I don't need to see the equation. I don't need to see algebra. Can you use the solver is what I want. Everybody's okay? Let's do some more examples. Suppose Gina invests $800 at a 7% annual interest rate. How much money will she have in her account after 5 years if the interest is compounded annually and then semi-annually and quarterly and monthly and weekly and daily? All right. Let's get this set up here. I got to make this a little smaller so I can still see the problem. All right. So annually, 5 years, 1 time per year. 7% interest. $800 out of my pocket, making no payments, compounding 1 time per year, enter. So $1,122.04. If I'm doing this semi-annually, how many times is that going to happen semi-annually? Twice, right? Sure. So I'm going to change to 2 compounds per year, and I'm going to change N to be 5 times 2. Oh, I shouldn't have done that. That's not right. It's just 5 still. Yeah, there we go. So $1,128.48. If I change it to be quarterly, number of compounds per year then is 4. And I update that, and I press enter. $1,131.82. Is this having a big impact, the number of compounds per year? Not so much, right? Okay, what if it's monthly? Compounds per year is 12. Changed a little less than $3. That's not having much of an effect. Weekly, I update to 52. Barely did anything, right? It was like $1 or something, less than $1. I go to 365. Oops. Oh, boysies. Okay. Yes, I know, that can't be negative. 365. It was less than $1, like 30 cents or something. What's the takeaway? Number of compounds per year doesn't have a ton of effect there, right? Not much difference. Now, I didn't write down any of this because I just did it in my calculator, right? Okay. Let's move on. Mara has $1,000 and places it in a savings account with 6% annual interest, compounded monthly. how long will it take before Mara has $4,000? So again, I have a PV of $1,000, so it's coming out of my pocket, so I'm going to make that negative. 6% interest rate, compounded monthly. I'm going to have $4,000 at the end, and I want to know how long, so that's N. So 23.1 or 0.2 years, right? Is everybody okay with how I jam that through the calculator? Again, this should be very easy if you're comfortable using the solver, right? All you're doing is putting the numbers in the right spot and asking the calculator what's the answer. The hard part is translating the words into the numbers that need to go in the right spots. Okay. Next one. Gwen has $600 to place in a savings account. What annual interest rate would she need, compounded weekly, if she wanted to have exactly $1,500 in 10 years? Okay. So we have $600 to start. Since it's out of my pocket, it's a negative dollars. We have 10 years compounded weekly to get to 1,500. And we want to know what that interest rate is. So I need about a 9.17% interest rate. Isn't this nice? Like, this is so much easier than doing the algebra, right? The algebra is a nightmare. This is super clean, really easy. Okay. Here's the hitch. If we are compounded continuously, you got to use the calculator. You can't use the TVM solver. But that's okay. All the letters still mean the same things. So it says Jack invests $800, 5% interest rate. How long will Jack have to earn $500 in interest? What is this supposed to be telling me? I'm going to need that to calculate the future value, folks. Is everybody okay with where I filled things into? Gianni, you're looking very intently. Are you all good? So I need a future value, right?
Yeah.
The future value is going to be the present value plus the interest earned.
Okay.
Right?
So use the date, right?
So I did 800 plus 500.
Okay.
That's 1,300. So yes, I just did that in my head. You're no problem. No problem. All right, I'm going to solve this by graphing because algebra is kind of yucky sometimes, and this is not too bad to do on my calculator. So X is time. I don't really know how long this is going to take, but it could take a long time, right? So I'll make like 30 years or something. The minimum, the least amount of money I'm ever going to have is the $800 I started with. I need to have at least space to get to 1,300, so maybe I'll go to 2,000 or something. And I go up by hundreds. That sounds good. Hit my graph. There we go. There's my intersection. That's what I want. Second trace, intersect command, enter, enter, enter. So about 9.71 years. Is everybody okay there? Okay. The next problem says you find an account that has a 6.5 annual interest rate compounded monthly. What would be the equivalent interest rate if it was compounded annually? Right? Everybody's okay there? That's the compound interest formula. I know that my R here is 6.5. Oops, that K is supposed to be 12 down there also. Everybody's okay? This is the same as like PV times to that, right? Everybody agree? Oh my God, come on now. Okay. And then if I want yearly, that's going to be like this. Right? And what I want is when this number is equal to this number. You guys see what I did there? How am I going to solve this? I'm going to graph it in my calculator. Find the intersection. All right, so I got 1 plus 6.5 over 1200 to the 12th. And then I have 1 plus R over 100. So X is going to be the interest rate, right? If it's 6.5, it's probably not going to be more than 10% if it's annually. And then the Y's, I don't know, but like, it's probably not going to be a massive number here. Let's just go from like -2 to 2 or something is probably enough. That's, oops, what did I do wrong? Yes, it's, let me see. That would do it. Put those in the wrong spots. Okay, there's the cross is happening somewhere over here, right? So second, trace, intersect, command, enter, enter, enter. So about 6.70%. Now this concept that we just dealt with, translating a one interest rate into an equivalent interest rate under a different condition, a different number of compounds, is a really important one in the real world. This is the concept called APY, annual percentage yield. This is standard practice when you're buying a loan. is that the interest rates will be given to you as APYs so that you're easily able to compare one loan offer to another. So now I have this in the way here. Sorry, that's why that looked so confusing. I'll be back in just 1 second. I just have to reformat some stuff because it's okay. All right. So it says, which savings account is the better investment? 7.8 interest compounded quarterly or 7.65 compounded weekly? We're just going to calculate an APY for each of these and see which one has the better annual interest rate. I know. Yes. Wow. Any questions as to how I plug these things in? It's the same, the R and K still are the same thing, interest rate, number of compounds. So I have 100 times 1 plus 7.8 over 100 times 4 to the, oops. Come on. Times 4 to the 4th minus 1. That's my first interest rate, 803. And then we have 7.65. And then weekly, so change the 4s to 52s. Which one was the better deal? Or which one's the better investment? The first one, because the interest rate is higher. That's all we're saying. So 803 versus 794. All right. So we talked a little bit about what an annuity is. This is the formula for an annuity. But guess what, guys? Who's not doing any annuities by hand? How are we going to do them? I'm going to use the solver on the calculator, right? So let's pull up that TVM solver again. And let's show you how to type this in. So at the end of each quarter, Sarah makes a $500 payment into an annuity account. Okay? So starts with $0. And because the money is leaving my pocket every month, I'm going to have $500. And since we're doing that payments per year, we're doing that every month for 12 years, or every month. So 12 is my compounds per year, or payments per year. The interest rate is 7.88% compounded quarterly. Oh, sorry, at each end of each quarter. Sorry, it's not 12 compounds per year or payments per year, it's 4. Excuse me. And then the interest was 7.88, it told me. And it asks, what will the annuity value be at the end of 20 years? So we want the future value there. Nope, that's not right. This must be times 4. There we go. That's right. So at the end of 20 years, that's 80 compounds though, or 80 investments. We'll have $95,000. That's a lot of money. Okay, and then next example says Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes $2,000 down payment and the annual interest is 6.7? All right, so let's think about this. How much money do we actually have to borrow? It's going to be the cost minus the down payment, right? Everybody's okay with that? Okay. So we'll have $16,000. We're borrowing $16,500 from the bank. That's what we're starting with. Oops, sorry. That should be here as a present value. And the loan, it says that we're taking is for 2.9%. Woo! That's post-inflation there, where we jacked up our interest rates. Good luck finding interest rate like that anymore. And at the end, we should owe the bank $0, right? How often do you have to make a car payment?
Every month.
Once every month. So the payments per year should be 12, and the compound should be 12 also. And we're doing this for 4 years, so we're making 48 total payments. And we want to know what the payment will be. So we should be paying out $340 or $64.49. It's negative because we have to pay that, right? Is everybody okay? So again, think about the negatives as just the flow of money. The $16,500 was positive because we'll take that money came to the bank to us, and then every month we have to send to the bank back. So negative, leaving our pocket, $364.49. And our last question, using the same information from the previous example, assuming that all of Maria's payments are equal, how much interest does Maria pay over the life of her loan? Okay. Well, we paid $364.49 every month for 4 years. So that's the total cost of the car, right? Well, I shouldn't say total cost of the loan. So $364.49 every month for 4 years. So that costs $17,460 or $495. How much did we borrow from the bank? $16,500, right? So the difference between those two will be how much we paid in interest for our loan. So minus $16,500, we paid $995.52 for the loan. That is it, guys. We've now finished chapter 15. You guys will, next class, I don't think I'm going to be here. I think Mr. Sharp is scheduled to be your sub. Your job is to work on your problem set, which, so 139 to 184 is the last section. Almost all of that should be done in your calculator, right?
Wait, when's our test that week? It's optional too.
It's on the calendar. So Tuesday's work day, Thursday's review day. The following Monday, I think, is the test. Or Grace, if you thought it would be easier, you could opt to do the retake instead of the double. Right? Like that might be a better option if you have one outstandingly low test grade somewhere.
I know.
That might be easier.
We have golf practice at 3 o'clock.
Uh-huh.
Maybe we like just 5 minutes early to beat traffic. We have to get in the course like tee off by 3.
I cannot dismiss you from school early. I'm sorry, but I can let you guys like sprint from the room at, as soon as the prayer finishes. I get it. I understand. Getting out is the hardest part. What's that?
Can I just change it to my old pants here?
That would be okay. That I can allow you to do. I don't have the authority to dismiss you